The first part that we want to talk about today is when we are doing pathfinding. We've talked about A star, we've talked about Dijkstra's algorithm, we know some limitations of those. But to use, for instance, A star, um, if you decide, say, to use A star in a game jam game, you have to create a graph structure. Uh, you have to create that underlying structure to determine what the path, what world you're working in, right? Well, what happens in a lot of situations, you've already created um, a mesh to describe what's going on in the world. And so, I don't know, some of you may have, in a previous class, um, looked at a navigation mesh, or it's called a nav mesh. Is that familiar terms? So what do you do? Basically, a low res polygon mesh that shows where an object can travel. So what do you have for a polygon? We look at usually convex polygons, which means you have some shape that often you might have a triangle, you might have other whatever kind of polygons you decide to use. But if you have a, well, let's say we have some kind of triangular situation, what happens inside that triangle? Any point you can just get to in a straight line, right? Any point inside one polygon is a straight line. Well, what can you then do if you want to find, you have some mesh that's describing where you can travel? Maybe you can work from middle point to middle point, or you can work um, in a dynamic way where you change which points you're going to. You're trying to find a path. Then that graph structure of from here to there and how far is it is already determined for us, right? So we don't have to add extra graph structure. The graph structure is there because we created our mesh. And then we utilize that. Then what do we use? We use A star or something to find the shortest path on that mesh. Again, that can update. We can do different things. Uh, we can make that not just go center to center, because if we go center to center, then what might happen? We might end up with a path that looks very, and what would you really want to do? You'd want to smooth that out so there's path optimization opportunities and so on to make that look more realistic. There's also things if there are barriers in the way and so on, depending on how finely tuned our mesh is. If it's very coarse, then you have to go way out and around things, even though they're only a little tiny portion. Um, and so sometimes that can look awkward. But what's the benefit to that? A lot less resources, right? There's a lot fewer resources used in the coarse uh, kind of mesh. So um, these are built-in um, tools now in Unity and Unreal and Godot, probably lots of other engines, because this idea started in the probably in the 1980s in robotics, and they called them a meadow map. So there was a this idea of organizing a rough structure of where you could travel, and then utilizing the existing algorithms like A star to find your path, but having that general sense of where you can go. Uh, and it wasn't until 2000, which now it seems like a long time ago, but in terms of the development of things, um, that's fairly recent in that sense. Because a lot of the algorithms that we're using, I mean, A star, how old is A star? It's a lot older than that, right? The algorithms that we're using um, are a lot older, but the idea that it was something that was being used in robotics and then didn't get carried over to games, even though the ideas, all the structure was there, it just took the right person to think about it and say, oh, wait a minute, I've seen this thing over here. Why don't we use that same kind of idea over here? Um, and so we may or may not do a lab of implementing the idea. But what happens? It's a tool that's already available to you. Again, in lots of engines. Um, so the idea is, instead of specifying what our additional graph structure so that we can then use A star, we have that graph structure kind of designed. Level designers are doing this kind of stuff anyway, so it's part of what's available to us. Let's utilize that structure so that we have our graph structure to build on. And then, um, if there are all kinds of issues if you have something that's 2D versus 3D, or if it's 3D, uh, it, it, are we making sure that we're looking at the right portion of the map and so on? So there's a lot of there's a lot of aspects that we have to consider. So it's not just automatically done for us, but it's still uh, a big step toward not having to add additional things and not having to specify. We can hide the graph theory, right? We can hide that so other people don't see it. They don't see this part of what's going on. They just see this character walking around in a way that seems as natural as it can be. Um, there's always all of the other stuff hidden behind that we don't want people to see, right? Um, so again, this is the way in most kind of situations that we would deal with in games, of where you would actually implement A star. You would implement it on this rather than constructing a different uh, graph like the one we had with the maps. That's perfectly fine for that particular kind of problem. Uh, we need something with a lot more detail to have a character that moves in a more realistic looking way. All right, so just a summary. This is mentioned in that text that I pointed out in a particular section, what 4.4.4, I think. And so they mentioned some of the quirks, some of the things that can go wrong. So if we do the lab, we'll go into that into more detail. If not, read that section anyway, just because it's a useful thing, useful set of ideas to think about.